Okay, welcome back from the break. Before the break, we implemented the jokes list, the joke by ID select, and the creating of new jokes. Now what is missing is the delete and the put. And I would suggest that we do it in the following way. You try it on your own, okay? I will show you later on how you do it. But let's take, I don't know, 10 or 15 minutes or something like this, and try to come up with a solution for the map delete and the map put. So these two functions here. Try to implement it, ask me if you have any problems, and try to test it, either with Postman or with the REST client, because it's not possible with the regular client, with the regular browser client, to send a delete or a put request. Okay, so you had some minutes. So you had some minutes to try it on your own. Let me show you a possible solution, how this could work. Let's think about the map delete first, okay? What do we have to do when we want to try to delete something? Let's see whether the joke dictionary offers us something which is called remove or something. There is a remove method and a try remove method. Let's take a look first at the remove method. The remove method tries to remove the value with the specified key from the dictionary, and it returns true if the key was found, false if the key was not found. So that sounds pretty good. So we can say if remove the ID, oops, sorry, I forgot to map the ID here. So int ID. So now here ID. If not remove, then we know that there was a problem. The ID was not found. And remove wants to have the out joke. That would be an out var. And if you are not interested in the joke, you can just say underscore. That just tells C#, okay, I will be given a joke, but I'm not really interested. If it didn't work, we can say return results dot not found, because we know, nope, this joke does not exist. And in any other case, we can say return results no content. That is a typical implementation of a delete. We try to implement based on the ID. If we can't find the element, we return not found. If we found the element and successfully removed it, we simply return no content, signaling the client there is no data anymore under that ID. Now the jokes and the put here is really similar in that we first have to try to get the joke with the specified ID. So what we need to do is first we try to read the joke. We did that before. If you take a look up here in the jokes/ID, we already have a code that tries to read the joke by ID. So let's simply reuse that line of code. I will copy it and put it down here. That gives us the joke. The only thing is we need to turn it the other way around, not try get value, and in this case we say not found. So if we don't find the joke with the given ID, we return not found. In the other case, we now have the joke in our hands. Here it is, here. And we can try to update it. In our case, in the map put, we do not just get the ID, but we also get the DTO. The question is, do we need a new DTO, or can we reuse that one? I will reuse it because it's perfectly suited for my task here. So let's say here, create joke DTO, new updated joke, something like this. But now I don't really like the name of the record anymore. It's called create joke DTO. You know what I'm going to do? I'm going to rename it create update, create or update. joke DTO. I think that is a better name here because now it indicates that this DTO is used for creating and updating jokes. That is just for making it a little bit more beautiful. That it's not absolutely necessary for the functionality. Now we can update the joke. So we can say joke.funLevel equals to updated joke.funLevel, and we can say joke.jokeText equals to updated joke.jokeText. Exactly that one. And finally, we return a results.OK, giving back the updated joke. Strictly speaking, we have concurrency problem here again. Imagine that we execute this line. We now have the joke, and somewhere in between here, at the same time, somebody calls a delete on the same job. Understand what I mean? That's a problem. Or maybe some users try to update the joke at exactly the same time. Then they overwrite the changes. These are edge cases which are, in memory, pretty hard to solve. We are not going to deal with that because in a few weeks we are going to switch from in-memory data to a database, and the database will solve the problem completely for you. Okay, so that is not perfect, remember that. Maybe I even ask you whether this is perfect, and the answer should be no, because we might have concurrency problems. But this is not the core topic of today's lesson. We want to focus on the API. So this is an edge case that I do not want to deal with now. Let's give it a try. I run it in my debugger. Let's go into the requests. Let's add the joke here. It worked. Now we have joke ID 1. Now we can try to update this joke. Put. That would again be the jokes with the ID 1. The content type would be JSON. And then we can update this joke. I will copy the data, but this time I am going to update the fun level to 5 because I think the joke is much funnier than I originally thought. I will do it and see. Now it was updated, so it works perfectly fine. If I try to update the joke that doesn't exist, I get a 404 not found. Exactly what I want to have. And finally, we try to delete this guy. Delete. Run it. No content. Exactly what I expected. If I call it a second time, then I get a not found. Exactly what I expected. And if I try to retrieve the list of jokes, oh, I just created the joke again. I'm sorry. I have to delete it again. I executed the wrong request. Now, let's get the list of jokes. This would be getting the list of jokes. It's empty again. So it works like a charm. Exactly what I wanted you to see. Let's quickly recap what we did so far. I mean, take a look at this one. Here we have just the documentation. So in total, our code is maybe 60 lines of code. We have the documentation on top. This is why I would say 60 lines approximately. And we have an insert, we have an update, we have a get all, we have get by ID, and we have a delete. That's nice, isn't it? Let's quickly discuss about what you think about this API. I would be really interested in that. So I'm glad that you like what you have seen here. And now we have 15 minutes left. Let's see whether we can run this thing here in the cloud. Okay? If you want to run something like this in the cloud, the simplest way of doing it is putting this stuff into a Docker container. Have you ever done Docker in some classes yet? No? Some of you are
Theoretically.
saying... Theoretically you have. Okay, theoretically you have. Good, 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 good. Are you familiar with Docker? A little bit? Are you a little bit familiar with Docker, or do you don't have containers in general? Don't have any idea about containers? Give me feedback. Good. So let me quickly show it to you. Maybe we are not going to. If you are lacking some basic understandings or fundamental knowledge about containers, then we are not going to put this into the cloud. But let me quickly show you how we can put that at least in a container and run it in a container environment. If you have Docker installed, you can follow along. If you don't have Docker installed, just watch for the last 15 minutes or 10 minutes or something like this. I highly encourage you to install Docker. It's really, really a must tool. It's for free for you, for education purposes. You can install it for free. If you have a Mac or a Windows system, you can install Docker for Windows or Docker for Mac. Docker Desktop, it's called. It's really working very nicely. And if you have a Linux computer, you can run Docker natively. You don't need any kind of Docker Desktop or whatever. On my machine, I have Docker running. Do I?
Yes.
Well, I should. Let's see. Yeah, here it is. See? This is my Docker, currently no containers running. See? Let me quickly sign in. I need to sign in, sorry. So where is Docker? Here is Docker. Good. So can we agree that next time most of you are, or all of you have installed Docker? Because we are going to practice a little bit with that. I'm not going to do a general Docker introduction. That would be out of scope of this course. But we are going to use Docker every now and then, and you will learn the basics, yeah, just by watching it doing. I think that's okay. Now, Docker containers are similar to a virtual machine, but they are much smaller and much more lightweight. So we can put our entire code that we built into a so-called container image, and then we can ship this container image, and everybody can put this container image on their computer or server and run it from there. That's super convenient. So for instance, I could give you my container image, and you can simply run it on your computer, and you get my entire API, and you do not need to worry about whether this is Python or .NET or Java or JavaScript. I don't care. You get the Docker image. It's small, it's tiny, it's fast, it's convenient. That is what Docker is all about. So, if you want to build a Docker container from .NET, the easiest thing is to just Google it. Create Docker image from ASP.NET Core. And the first one is just the correct link, Docker images for ASP.NET Core. And if we scroll down and scroll down and scroll down, at some point we get a so-called Dockerfile. You see that one? This is what you need. It's the kind of recipe of putting the application into the Docker image. That is one possibility. There is another possibility, which is even simpler, and I can show you that in the upcoming weeks. But for now, I would like to demonstrate that to you. So if you Google that and copy the Docker file, here it is, then we simply have to create a Docker file in the same folder as we are here and paste it in here. See? Yeah, I can install the extension. Yeah, that's fine. There is a separate Docker extension to Visual Studio Code. The second thing that we have to create is a .docker ignore. You're familiar with git ignore, right? We've done that before. Very good. So Docker ignore is the same, but for Docker. So we can, for instance, tell Docker, hey, Docker, ignore VS Code folder. Ignore the bin folder. Ignore the object folder. Ignore the... What else can we ignore? The requests .htdp, all the files and folders that have nothing to do with our application at runtime, we can simply ignore them. That is what we put into the Docker ignore. Now let's take a look at the Dockerfile and try to understand it. First, we need to do a tiny little change here. We have to say that should be SDK 7, not 6, because we are doing .NET 7, not 6. We discussed that yesterday. Next one, we do not have a solution file. We just have a project file. Solution files will come later in this course. For instance, if you have a class library with your logic, a web API, and unit tests, then you would have 3 projects, and you put them together into a single solution. But for now, we only have 1 project, so no solution yet. We can keep things simple. Our app is in the local folder, so we don't need a folder name here. We don't need a folder name here. And then the system runs .NET Restore. .NET Restore goes into the internet and fetches all the so-called NuGet packages. It's like NPM in Angular, right? Like Maven in Java. Okay. So it just fetches all the libraries from the internet. Good. Then it copies everything else. We can get rid of the path here. We don't need the path. We really don't need a work directory here because we don't have a path. And then the system says, .NET publish, give me the release version and write the resulting thing into the folder app. /app means write it into the folder app. No restore means, hey, I already did a restore up here, you do not need to restore again. Next one. This is all the building of the application. It's building the application. It's generating the binary, the DLL. And now comes the deployment part. We simply say, I have an ASP.NET 7 application. Please copy from the build container the app into the current folder. And finally, we have to select the name of the DLL, and it's called hello-ASP.NET, depending on the name of your folder. Here, hello-ASP.NET, and we are done. That's it. So the whole recipe says, restore the external packages, fetch everything we need from the internet, build and publish the entire application, release mode, so that we can put it on a real web server, and copy everything into an ASP.NET base image. Base image is the basic image with the Linux distribution and the runtime environment that Microsoft provides for you. That's all you have to do. So finally, we can run this guy. Looks like this, Docker, build, then we give it a name, -t. I use my username from Docker. So if you sign in at the Docker website, you get a username. And typically you use your username as a prefix. Okay, so rstropic is my username on Docker. And then we say hello ASP.NET, something like this. And then we tell the system where it can find the Docker file. In my case, it's in the current folder, so I simply say current folder. Press enter. And that's essentially it. It failed. Okay, very good. Could not read Dockerfile because I'm in the wrong folder. I'm in the wrong folder. I'm sorry. I'm in the wrong folder. Now I'm in the right folder. And try it again. Nice. The system recognized that I don't have the latest version of ASP.NET 7 container image on my computer. I have all this stuff installed at home at my work computer. This is my teaching computer. And it seems that I have never done that before. So it now uses my internet connection to go to Docker and say, hey, I want to run ASP.NET Core. And I'm not interested in installing Linux and .NET. Just give me a ready-made image. It's like a ready-made virtual machine where I just have to put my files on it and simply will work. This is only happening once, okay? And it takes a little while. As you can see, this has a size of 150 megs. But currently we are lucky. The school internet is pretty fast. So we should be able to finish that before the end of the lesson. Let's be patient for a few more moments. We are at 80 megabytes. Any questions so far? Good. While this is downloading, I can show you where all these images come from. They are come from a website which is called hard.docker.com. See? And here we can look for so-called base images. Imagine that you would like to run, just as we had it now, ASP.NET Core. Somewhere it should say Microsoft ASP.NET Core. I can find it, but believe me, it's there. If you want to run something based on Node.js, just take Node.js. There is a ready-made image for that. Do you want to run PHP? Here, there is a ready-made image for PHP. Do you want to run something based on Java? OpenJDK, for instance. Here you are, OpenJDK. Do you want to run a database? Postgres. Here it is. You do not need to install Postgres. It's already there. Do you want to have MySQL or something like this? Then Google for MySQL. Do you want to have Microsoft SQL Server? It's already there. The only thing that's not there is Oracle. Yeah, but yeah, let's not discuss that. Otherwise, I'm going to get angry. And I don't need to. Okay, hey, our code is ready. So it pulled from this website the ASP.NET Core, executed the whole script, and now we are done. We simply have to say Docker run. T means show the output on the terminal. Do a port mapping. That would be, for instance, map the port 80 to the port 8080 on my computer. I'm simply doing port forwarding, like you at home. If you want to play an online game, you have to do port forwarding on your router, right? You have done that before, probably. Yep. This is exactly what we do, but we do it on software, not on hardware. And finally, we say the name of the container. That's rstropec hello ASP.NET. Yep, it's allowed to access my firewall. And you see, it's running. And I can show you that this really works by simply saying localhost 8080/jokes. And you see, this is our API running in Docker. So it wasn't really complicated. Microsoft really provides everything you need to put your web APIs into containers. And once your web API is in a container, you can run it everywhere. You can run it in AWS, you can run it in the Google Cloud, you can run it in the Azure Cloud, you can run it in the Leo Cloud, which is in our school's basement, a Kubernetes cluster. You can run it wherever a container runs. Anybody has a Synology device at home? There's network attached storage boxes that you plug in and you get lots of, no, not Synology? Whatever, they support containers too. Do you see the value? It wasn't complicated, right? And I can even go so far to say Docker push rstropec / hello ASP.NET. It will now take what I have once I logged in. Sorry, I have to log in. Log in, come on. And it's rstropec and it needs a password. Oh my god, should I do that? No, it's too much work. But if I log in, I can simply say Docker push, and then my application is available on the internet, and you would simply have to say Docker pull and run it, and done. It's the easiest way to ship software. It's so easy. No USB sticks, no manual copying, just push it, pull it, done. That's Docker in a nutshell. And the only thing that I want you to take away from these last 10 minutes is ASP.NET Core works really, really nicely with Docker. And that's the best way of putting your web APIs into the cloud, in whatever cloud you want. So please, take this as a homework. Make sure that you have Docker installed, because I would definitely like to do some exercises in the upcoming weeks where we really take our API and put it into a real cloud. So you see how this really works. Good. And that's all I have for you today. So we managed to solve our goal of having a small API. And with that, we'll see each other next week.